Hi everyone. I'm David, and I'm going to be showing you guys some cool stuff that we can do with WebAssembly and Rust. Yeah, everyone hear me? All right. Yeah, cool. Cool. So, what is WebAssembly for starters? So, WebAssembly is a new kind of binary format for the web, and it can run in a web browser. And it basically means you can run kind of high performance code in the web browser in a kind of safe, secure way. We can compile low-level languages like C, C++, and more importantly, Rust to run in the browser and do some really awesome, cool stuff. Cool, so we'll get started, and I'm just going to be giving a few like code examples and a few little demos, kind of easing us into what WebAssembly is and kind of how it works. So the first example is, so I'll just, maybe I can change my theme. I'll just put a light theme on my, let's go something light. Is that better? Yeah. Yeah, cool. Okay, so we've got an HTML page. There's nothing really exciting here, except we're just loading a JS file. And probably the most important thing is here, we've got type module. So that means we're loading an ES module. But what we're going to do is we're going to add two numbers in WebAssembly. So WebAssembly has two formats. So you've got a text format with a .wat extension. So this is the WebAssembly text representation, and it's kind of like, it kind of looks a bit like Lisp with S expressions. And so this is kind of how you can kind of handwrite WebAssembly in this format. And so this is a simple kind of add function that takes two parameters, in this case i32s, and then it will call an add operation. So it's kind of like, it's a stack-based machine. So it kind of puts two things here, gets the two arguments, and then the add operation kind of runs on the previous two, and then it'll return the result of the add as an i32. So this format's good for like being able to kind of see what's going on inside your module, but it's not really that compact. So WebAssembly has a binary representation too, the .wasm, and this is kind of like really compact, efficient, over-the-wire format for WebAssembly. So you can convert between the two really easily with a command line tool called wat to wasm. You can also go the other way around with wasm to wat. So here I've compiled this, running this command to get the add.wasm file, and it's a binary file, so I won't show you the contents. And then we want to load this into our web page. So I've kind of got this JS file. So this is loaded from the index. So what we do is is that readable? I'll just make it a little bit bigger. So what we do is we use this WebAssembly instantiate streaming function. So this is kind of how you would, you can kind of compile the WebAssembly to like native machine code as you're kind of fetching it over the wire. So we do a kind of a fetch request to that file, and then we get an instance, a WebAssembly instance out of that, and we can access the exported add function that the WebAssembly module exported. And we can call that, get a result, and then print it. So it's pretty basic. It's like the most simple thing to do in one of the most simple examples in WebAssembly. And I'll just show that running in the browser here. So I can open up this example, and you can kind of see in the console that we printed 2. That was 1 + 1. Yeah, so that's kind of your first taste of WebAssembly. No Rust yet, but we'll get to it. Next example is pretty similar. The only different, sorry, I'll show you the JavaScript here, where the only difference is we're passing in a import. So the WebAssembly module can export things, and then you can kind of import JavaScript things like numbers or functions or whatnot into the WebAssembly module. So here we're giving the console log function into the call to instantiate streaming. So before we had an empty object here, now we're giving this kind of object that has this log function. And then so this version will call add, and then it will log the result. It'll do a console log in from the WebAssembly side, but it's actually kind of going out and calling this function here that was passed into it. And we did the same thing where I run the, sorry, I'll show you the WebAssembly, the WAT file. So this is pretty similar. I'll bring up the other one here. So that was the old one. So here we're declaring a kind of import. So we've got this log function that we're importing, and it takes an integer parameter and doesn't have any return. And then this add and log does the same thing we did before. Add our two arguments, and then we call at the bottom we call our log function. So giving that result of the add into the log function here. So it does pretty much exactly the same thing when we run that example too, because from the JavaScript side, we call add and log with 1 and 1. So the result is 2. Okay, but this is kind of how you do kind of raw WebAssembly. But if we want to bring Rust into the mix, let's do add in Rust. So this is without any libraries. Rust supports compiling to a WebAssembly target. So I'll show how it's compiled in a second, but this is creating a WebAssembly, creating a Rust exporting a Rust function with the C calling, standard. So in our cargo toml, we're declaring our library as a C dynamic library. So it can be kind of linked to. And then when we build it, we just do a standard cargo build target 32 wasm unknown. And so that will compile instead of like normally you get like a .so file if you're on Linux, or a dilib or a DLL or whatever. In our release, in our target. Yes. Yeah. So this target you have to go add this target to your Rust compiler. So you have to do a Rust up add target wasm32 unknown to get that. But then the Rust compiler will support that, no problem. So it'll compile it into the target folder, and you get a WASM file out. And VS Code has a really cool feature where I can click on this, and it's a binary file, but it'll actually kind of show you, it'll actually do the convert to the WAT for you. So we can have a look at that, what the output was, and that's the binary file, but then it kind of snaps into place. But you can see it's kind of pretty similar to our raw add. This is the kind of the guts of it, which is pretty similar to what we hand wrote. So that's kind of the output of the Rust compiler. Pretty cool stuff. Yeah, so we do the same kind of thing to load this like we did before. this is exactly the same way. We just do a fetch to the file, and then we can call that function and we log in the result here. Cool. So I think we're pretty much over adding numbers, and we want to kind of get into something a bit more hardcore. So we're going to do a hello world. So at this stage, WebAssembly is kind of at an in browsers, it's at an MVP stage. So at the moment, you can only really send numbers between JavaScript and a WebAssembly module, and then you can also kind of access the raw memory from the WebAssembly side. And we'll get to that later. But sending strings between JavaScript and Rust, you kind of need to go through a few hoops. But luckily, the Rust team have built a tool called WebAssembly, which will kind of help us out with doing interop between JavaScript and Rust for pretty complex types and whatnot. So here we're bringing in this example, we're bringing in a library, WebAssembly, I mentioned before. And then in our lib file, this example is going to, you're going to call the greet function, and you give it a string, and then it's going to alert that to the screen. So it's going to call the JavaScript alert function from the WebAssembly module. So you can kind of see the code. This is the way in. We're going to call this. We're going to give it a string. Then we call format. We say hello, then that value, and then we call alert. And we're going to call this is like an external JavaScript function that we're going to kind of use. And so you can see we've got these two annotations here, WebAssembly. So this is going to do the magic of kind of gluing this function to JavaScript, and it will generate some kind of JavaScript for us that'll kind of do some magic under the hood to make it all work. And also bring in that alert function like we did before manually. We brought in the console log function. It'll bring in the alert function as an import into our WebAssembly module. So there's a few little things we've got to do to make this work. And then when we compile this a little bit differently, instead of kind of calling cargo build with the target like we did before, we're going to use another tool called WebAssembly. WebAssembly basically will build your WebAssembly project, your project that uses WebAssembly, and it will kind of generate. It'll spit out the glue.js, and it will create a npm package for that module with a package JSON and everything. So you can see here, this is the output of running WebAssembly build target web. We get a package JSON, which describes our module. We've got this blob of JavaScript here. So this is the glue code that I mentioned. We won't really go into that. We even get some fancy TypeScript type definitions for what our module has. So you can see our greet function there takes a string and is void. And then we get the actual WASM module itself. And we also get this kind of handy init function. At the moment, I'll show you on the JavaScript side how we load this. So you can see we're importing that we point to the glue.js, and we're getting our greet function that we exported from our module, and then this init function. And this init function does the kind of streaming compilation thing that we did manually before. And in the future, when browsers support loading like WASM modules kind of directly using this module import kind of syntax, you kind of won't need to do this bit manually. But at the moment, we do this, we wait for that to finish, and then we call our function that we exported out of so this is calling the glue code, which will then call our Rust under the hood, and it will do all the fancy things under the hood needed to convert this string into the bytes that need to get into our WebAssembly module to be processed by Rust. So let's run that example. So the add Rust, we don't need to see, just prints 2 again. So you can see here, wow, we get an alert, hello Rust meetup. Pretty impressive stuff. So the WebAssembly module kind of has a block of linear memory when it's kind of executing, because languages like C and C++ and Rust kind of expect to be able to allocate memory and deallocate memory. So we kind of give them this place to do that, which is this block of linear memory that the browser will provide, and we can actually access that to we can access that data from JavaScript and change things, and also access it. Yeah, I'll just show the example. So I've got an example where we're going into the memory. So what we're going to do in this example is we've got a function that we're exporting called makeString. We're going to create an owned string. Then we're going to get the raw pointer of that string, and then we're going to get the length of that string, and we're going to return it out. And then JavaScript is going to then look in this block of linear memory and find the string data in there using these 2 values. Something we need to do is we need to say Rust, don't free this memory when this string goes out of scope. So we do this mem forget, so Rust doesn't do that for us. And then we're returning this struct here, which has our pointer and our length. And that's basically all we're doing here. And we return that struct. On the JavaScript side, we can get this is similar to our previous example where we kind of get our init function and our make string function. Before it was greet, but now when we call init, we can get access to this memory object, which is the memory of that WebAssembly instance. And what we're going to do is we're going to call our we'll use this a bit further down, but we're going to call our make string function and get this raw string struct back from that, which has those 2 parts, the pointer and the length. So we're going to get them out of that struct. And something we need to do is we actually need to call free on that struct, because otherwise we'll have a memory leak, because when Rust doesn't know when to free that, because that's living in this struct is living in that linear memory as well. So we want to free that up. And then we're going to just log that details of that pointer and the length, just for info. And then now we're going to get a view of that data that string pointer is pointing to. So we create so we use this constructor here to build a uint array of the data, and we're going to log that. So this takes the memory buffer and where we want to look and how much data we want to view over, and then we're going to print that out. And then we're just going to decode that into a string. So we use this is a browser API, the text decoder. So this will take a byte array and turn it into a JavaScript string, and then we're going to log that string. So if we remember from inside the Rust side, it makes a string called raw string from Rust. So we're going to have a look at what this does when we run it in the browser. So the first log is, this is the memory address for that string. And this is the length. And then this is the raw bytes for the string. And then we print the string. So that's kind of how, if you want to do a lot of kind of sending data between Rust and JavaScript, you probably want to do it in a similar way like this. You don't really want to have it as return values from functions, because then it has to kind of serialize it and deserialize it. And it's going to be pretty slow because you're going to be copying a lot of memory. But if you kind of give pointers to this linear memory, you'll be able to do things a bit more efficiently. Yeah, go ahead. So we're freeing that struct that was created on the Rust side. And so when we've, this is the struct that we created. So this is, I did this because we couldn't return a tuple with the two things. So we wrapped it in a struct, and we're just freeing that struct that holds the pointer and the length. We're not actually freeing the string itself. Yeah. No, the linear memory is not garbage collected until the whole WebAssembly module kind of, yeah. So the string itself is not going to get freed here at all, because we haven't got a way to free it. But when the whole WebAssembly module kind of is, when the page refreshes, obviously everything will just go away. So you got to be careful about memory leaks when you're working with WebAssembly. You have to be more conscious about what you're doing with memory. Cool. So that's kind of how you kind of look into that raw memory. We're going to do something a little bit more exciting now. We're going to do DOM access from Rust. So this one I'll show you the example first, and then we'll kind of show how it works. So a button is rendered to the screen. We click it, and then it prints a paragraph in, it inserts a p tag into the DOM, and you keep clicking it and it inserts more. Yeah. So we're going to have a look at how that works in a second. So all of these examples, that HTML is empty. We don't have anything on the DOM. You can see here we've got an empty body. We've just got importing our module. So we'll have a look on the JavaScript side. You can see here we just import our init function, and here we don't actually even call any functions. We just call init. And we'll see what that does in a second. So before I go into the Rust, we're going to have a look at, I'm bringing in a few extra libraries here just for a few more useful features. So we've got this library here, console error panic hook. So this allows us to have nicer panics on the Rust side. Normally, when you panic, you're going to just see this error like unreachable code in the JavaScript console, something like that. But we want to stack trace in JavaScript. So this is a way to kind of give you friendly stack traces in the console when Rust panics. This one, alloc. So this is a more efficient memory allocator that efficient in kind of code size. So it'll mean the WebAssembly module will be smaller. You might have slower allocations, memory allocations into that linear memory, but it'll be a smaller binary in the end. So it's kind of optimized for code size. So that's often used in WebAssembly modules. And then we've got this library called WebSys. So before in our Hello World example, we said we wanted that the alert function. We wanted to bring that in from JavaScript, and WASM bindgen kind of figured that you wanted alert, and it did the import for you. But we don't really want to have to specify all the functions that we want to bring from the web APIs and do something like this every time we want to use it, and provide the type signature of that function. So this library that we're using here, WebSys, this is kind of a wrapper around, like a raw wrapper around all of the web APIs. And there's a similar one called JSSys, which is the JavaScript APIs that you'll have in any JavaScript environment, like Node or the browser. But this is specifically like web APIs, so things like the document and HTML elements and events and things like that. So we're going to use that in this example. So here's our code for our example. You remember we didn't actually call a function in the JavaScript side. We just call init, and then it will just run. It just runs automatically. That's because we've got this kind of WASM bindgen start annotation. So this is kind of like saying this is kind of like main for your program. When the WASM module initializes, it'll run this function that will do a few things. So what we're doing is we're calling into this this other module here, set panic hook. This is just a bit of boilerplate code here to set up that panic handler that I was talking about before. That will turn your stack traces. Will show you stack traces in the console, and I'll show you what that'll look like. I'm just gonna compile this. Give me a second. And we're gonna refresh this page, and you can see here, panicked at example panic, and we get a stack trace here in our console. And if we didn't do this, if I take that away, I'll show you what the panic would normally look like. You'd normally just get that. So you don't really know what happened or where. So that's a pretty handy debugging feature. Cool. So, and up here, this is setting up our allocator. I was talking about alloc before. This is kind of setting your global allocator to be this. Cool. So you saw the example when we ran it in the browser. We have a button, and when you click, it adds something. It adds an element to the DOM. So we're going to need a callback function to do that when you're on the on-click handler of a button. So we create, we'll come back to the callback in a second, but first we want to create a button. So we're going to get access to the window object, and we get this out of WebSys, that library that I was talking about. We unwrap that, get document. So now we've got document. So now we do document.createElement. So this is a kind of what you do in JavaScript normally. We're creating a button, and then we're kind of doing this cast into an HTML button element. So now we've got that here, the HTML button element, and we're going to do a set inner HTML click me, which is the text for that. And then we're going to append that to the DOM. So that'll add that button in there for us to click. Cool. So then we want to set an on-click handler. And this is kind of where it gets a bit more complicated. We've got this closure that we created up here, which is turning a Rust kind of function into a JavaScript function. And so we've got this add message function. I'll show you the body of that in a second. But we create this callback, and then we do some kind of fancy stuff here to to feed it into this on-click, this set on-click handler. It wants a JS function. So this is kind of how we get access to that. And then we need to kind of tell Rust again to like, don't free this callback, because this callback is going to be global. It's going to live around, it's going to live forever. We don't want to free that. Otherwise, we're going to run into problems when we click that button later. It's going to try and execute this code, but it's not there. And this is pretty simple. What we do when we click the button, we just create a paragraph. We set the inner HTML, and then we append it to the DOM. So that's basically what it does. And you can imagine from here, you could do all sorts of stuff. But what it's doing is each time you're doing one of these calls, it's kind of going out to JavaScript to talk to the DOM. And you might have a bit of inefficiency there if you're doing a lot of kind of DOM, like JavaScript calls. But in the future, WebAssembly is going to get some more features where we can kind of do low-level native to native kind of DOM calls. And that's going to come soon, where these calls it'll be calling the browser's native code that implements like set inner HTML kind of directly from the WebAssembly module without going through JavaScript. And that'll be a good deal, like a game changer when that comes. We're going to bring massive performance improvements. So that's all of the kind of examples I've got. If you guys have, like, I've got something else that I'll show you at the end, but if you guys have any questions, happy to answer questions. Yeah. Yeah. If you forget to forget, yeah, I'll show you what happens there. I forgot to forget when I was making this, and I ran into this weird error that I'll show you, and it was. So I'm going to build this again, and then refresh. And when I click, we get this error. Error, closure invoked recursively or destroyed already. So that's not very nice. So we've got to not forget it. Yeah. And while we're here, there was another example where I did a forget in the memory example where we have the string and we forget it. I'll show you what this does when we forget to forget. So before it printed this string, raw string from Rust, and now when we go look at this, we get a bit of garbage at the start of our string, because Rust has probably done something with that memory, and our string's not in there, at least the first part of it. Yeah, it's done some zeros, and then there's an 8 here, so, and a few other things.
Use the JS string from the JS
JS sorry?
Yeah, I used the JS string from JS and it doesn't need to do this.
Yeah. Yeah, so this was just a kind of an example on showing kind of how if you wanted to kind of get low-level access to some bytes that were allocated in Rust, you wouldn't do this. This is not how you would send a string back. You would use wasmbind gen to kind of give you a nice binding back. But this was just kind of a little bit of an example. Like, say if you're doing some kind of rendering of something in Rust, rather than sending the bytes back as a return value, you might just have look right into the linear memory and kind of read those bytes out and do whatever you want with them on the JavaScript side. Yeah, well, good that you asked that. I've got a few I've got a few further reading links. So I'll send the source code here for all these demos. I'll post on the meetup group so you can kind of see these links. But there's a book called the Rust and WebAssembly book. It's like a online book. It's not that long, and that has some good kind of examples. Another great one is the WASM BindGen guide. This is even longer, and it's got some really good stuff in there. I'll just give you a little sneak preview. So it's a bit small, but we've got kind of examples on like how to do things like do WebGL with WebSys and all of this juicy stuff here. So like I'm only kind of scratching the surface of what WASM BindGen's capable of. It can do some really awesome stuff. And then there's like one of those awesome lists that has links to a lot of cool goodies and stuff that you can kind of read in your own time. And then docs for JSSys and WebSys are pretty handy. And then there's some awesome blog articles on the Mozilla Hacks blog with some really cool cartoons to like describe how things work at the low level. Definitely check them out. There's a really good one here talking about the post MVP future for WebAssembly. So some of the new, like more advanced features that are going to come soon. That one's a really good article. So for the 64-bit integers. Yeah. Are you talking about like the big int support? Yeah, I'm not sure how that. If I don't think WebAssembly has support for that. I'm not sure. I actually don't know.
I know that the Chrome has maybe support right now, but Mozilla Firefox doesn't have.
Yeah.
The proposal is only a little bit. So it's a bit ugly because we can't use USARs. So whenever we index an array, the data have to be just
yeah.
To a 32-bit.
Yeah. So at the moment, yeah, WebAssembly is only 32-bit, but there is plans to bring 64-bit. Yeah, that's not how I do that. Cool. So I'm pretty much done, but there's one more kind of little demo I want to show, which is a little project that I've been working on, rendering a Mandelbrot set fractal in Rust. So I'm not going to go into the code for this one, but I'll just show a little demo of it. So you can kind of see that there. And as I kind of click in, it's going to zoom into the image and you kind of, yeah. So this is rendering in Rust, and then there's just printing the bytes into a canvas, basically. Well, at the moment, I've kind of got the iteration count pretty low. So you can see as I zoom in, I've got it as 100 iterations. So I can crank it up to 500 and you'll see more detail, but it'll be a lot slower each time I click. Yeah, so at the moment, this is all single threaded, even though the problem is like really easy to parallelize. WebAssembly right now is only single threaded, but it's going to be multi-threaded soon. Yeah, so yeah, so they disabled the shared array buffer because of the Spectre kind of things that happened last year. Yeah, so you can actually use web workers, which are kind of like separate threads, kind of from. Yeah, you could, but then it wouldn't be doing it in Rust, would it? So like I could be done in WebGL, but yeah. At the moment, it's just running on a single thread. But I'm looking at optimizing it a bit more with probably web workers to like break up the work for a few different threads. Yeah, that's a little project that I've been working on. Yeah, that's pretty much it. Any more questions? Yeah. So yeah, good that you asked that. So there's an article here called Standardizing WASI. So what is WASI? Is a new kind of interface, like a system interface for using WebAssembly in places outside of a browser. So you can use it to, it's a way to kind of talk to the operating system in a kind of safe way. And it's being used in CDNs for doing like edge computing, and it's being used in like blockchains for doing kind of smart contracts and things like that. There's some really cool uses of WebAssembly around. Yeah. 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 I haven't really looked into that kind of stuff yet, but yeah, it sounds interesting, like writing a whole front end app in Rust. But I haven't. Yeah, I haven't really played around with that yet.
I'm thinking about the browser inside a browser.
Yeah.
The reason for that is that this thing can be just a, say, straightforward proxy server. So we don't need a proxy server. We just load the website. And this is organized as a proxy.
Yeah, but like at the moment, WebAssembly can't really access the outside world. You kind of need to feed it things that let it access the outside world. So you'd need to give it a way to talk to the network, right? So it's not, and
no, I'm just thinking that the WebAssembly will do the rendering,
yeah,
the stuff,
yeah,
all those rendering stuff, calculation, putting things into the right place, sort of things. But the basic things I can just go back to JavaScript and let the JavaScript access them.
yeah, yeah. It's like the future is just like going to be amazing with WebAssembly. You can do it. You'll be able to do anything inside a web browser with WebAssembly. Yeah. Yeah. Yeah, I'm not sure like the timeline, but definitely check out some of these articles like on the Mozilla blog. They'll talk about like the progress they're making in efforts like that. Yeah. Yeah, exactly. That's something that's definitely supported. That tool, WasmPack, that creates the tool that creates a node package for your thing. You can package that up and then use it from any JavaScript project, just like the way you would use, like you can push it up to npm and then download it, and you might not even know that you're using a WebAssembly module under the hood. But one day maybe you might see, for example, Ruby or how we've got like C native extensions that I know you can do them in Rust already, but they're not safe because they're not in a sandboxed environment. So you might have one day have like a WebAssembly runtime kind of built into Ruby or something where you can do native extensions in WebAssembly. Yeah, but you could definitely do that in Node already today. You don't need, you can run WebAssembly in Node because it's just V8 and V8 already supports WebAssembly. So you can do some really cool stuff with WebAssembly.
Yeah, you have this one file there, the bg.p.ts. You have it so
yeah, so this one is kind of the API of the raw WebAssembly module, the types definition for that. Because we've got here, this is the types for the glue code. So this is like the way that I will interact to my WebAssembly module, but this is kind of the way that glue code interfaces with WebAssembly. You can see it has access to the raw memory, and then it's got some other things that it does. Yeah. I don't know the details of what all of this is doing, but it looks like it's ways to free things, free memory. Cool. Any other questions?